Okay.
Hi, my name is Rich Blaska. I'm the owner of Smart Elevator Tech. And we're here in Waterloo, Wisconsin at our factory at Metalworks. And I'm here to show you the second generation of the powered Retracta ladder. This is a power-operated retractable elevator pit ladder, specifically designed to extend greater distances than a typical ladder. This one extends out from the wall 36 inches, 3 feet. And it collapses to within 6 3/8 inches. This is mounted on Unistrut right now. This is a test platform. We're here in the factory. Normally it'd be mounted to the concrete. So this bracket here and all these brackets will be mounted onto the pit and concrete wall. Here we have it mounted on the brackets so we can do testing and adjusting. So from the outer edge of the back edge of the bracket to the outer edge of the ladder, again, is 6 3/8 or 6 1/2 inches when it's collapsed. Typically there is 7 1/2 or 8 inches between the wall and a car. So this fits in a typical application. Again, the purpose of this ladder is if you have a very wide platform car, like 8-foot wide platform, the distance from the door unlocking device to the ladder has to be within 39 inches to meet code. And a lot of large cars, like the 8-foot platform, it's impossible to do that. There's no way to keep within 39 inches. So this ladder comes out to you, so that when you are entering the pit from the elevator door frame, it's right by you. What we're going to do here is I'll show you the components, and then we're going to operate it. This is a linear actuator. This is the second generation. This is a Linux L36, 1,000-pound lifting force, 4,000-pound holding force, and it's attached to the bracket structure here. It's all part of it. This is set up to operate on a separate key switch. We can also do it through the elevator controller, which we call option A. This is option B, where we provide 110 volts either through the pit circuit or dedicated circuit with a disconnected machine room for the ladder. And the gray box up above there is the controller for it. So 110 volts comes into the controller, and then it's transformed to 24 volts DC to feed the actuator. And this is the control voltage for up and down. This is pretty much a standard hoistway axis key switch station, and we supply these in standard NEMA 1 and NEMA 4X as well. So right now we're going to operate the ladder. I'll turn this to the down position. And the ladder extends. You can see it's coming out. It takes about 11 to 12 seconds for it to deploy. And when it lands on the bottom, there's a limit switch built into the actuator to cut the power when it lands, so it's not under force. And now it's relaxed. This is in a slotted hole. There's a complete adjustability here, so if you're slightly off, high or low, you get it set up so the ladder lands, and so that this is loose. You tighten these bolts, and then you drill out the hole here, and you put in a roll pin that comes with it. That pins it for good. As you can see, these pans are structural. The purpose of these pans is to withstand a 500-pound lateral load. On a previous test, we hooked up a dynamometer to this, and we cranked it up to 640 pounds, and the ladder deflected maybe 3/16, and then it popped right back to center again. You can see this is extremely rigid, and that's the purpose of these pans, is to give it that lateral rigidity. Because you're entering the ladder from the side, from the entrance, so you don't want to have any play when you're out 3 feet like that. These pans are not intended to be stood upon, but you know, it can obviously hold the load. You can certainly put a toolbox or whatever you want on these pans. As you can see here now, it's 36 inches from the mounting surface to the center of the ladder when deployed. This ladder that we're looking at, as you can count the rungs, is for a 5-foot pit. We have 5 rungs, 12 inches apart. It's 16 inches wide. We have our ladder line for the adjust the ladder, which is a manual or a stationary ladder, the Retracta ladder, which is a manually operated retractable ladder, and the powered Retracta ladder, all use the same ladder components. You can even see there's some holes in it that are provided. That's because on the different models they're used for different things. Those holes are for the manual Retracta ladder, so that way we have the same ladder sections. These are traction tread rungs. These are formed channel shape. They're the strongest rungs I think you can buy. It's got an incredibly great gripping force to grip your shoe. Just a lot of adhesion there, and you don't have to rely upon an adhesive type tack paper or like sandpaper type material that can peel off and get plugged up. When these stay gripping, regardless of dirt or oil or any other substance. These are painted ocean safety yellow, which is ideal so you can see it. Most ladders are painted black or rust preventative color or something that you can't see. The pits are commonly not that well illuminated. Our ladders you can see. Back to the operation of this retractable ladder. This is a removable fork, a pull fork type, rotating cam, NEMA 4X, IP67 forced contact switch. You can see up there between this bracket that mounts the box and the switch up there, that's the switch. When this ladder leaves the wall, if it moves about 3/8 of an inch, this rotates the forced contact switch, and that switch is wired in series with the elevator pit switch. Exactly the same as the pull switch in the pit. So as soon as this ladder leaves the wall, it opens the safety circuit of the elevator system so the elevator cannot move. So you cannot have a collision between the elevator and the ladder. The ladders are completely ambidextrous. We mount it on either side. We actually, for the powered retractor ladder, we set that up in advance for you. So all you have to do is assemble the ladder sections, put the bolts in for the pit pans, and mount it on the wall. There's great flexibility on where the bracketing can go. It depends on the height of the ladder. We go from 3 foot all the way to 15 foot, and just by adding either 2 foot or 3 foot sections. All the tops are 4 foot tops with the bar across the top and the top rung, and then the bottom sections. As you can see here, this is a 5 foot section. Like I said before, it's completely ambidextrous and go on either side. These brackets are all exactly the same. So if you did misorder, you could reverse it in the field, but normally we have an order form that verifies which side of the hoistway it's going on. So earlier I mentioned that it's typically for the wide platform car where there's too great a distance to go between the entrance and the wall. Oddly enough, most of these, or about half of the ones we've sold so far, were used where the door, there was a side opening door, but for one reason or another, the ladder couldn't be located on the strike side of the door. In one case, it was an old elevator and the counterweight was there, so immediately in from the strike was where the counterweight was. You certainly couldn't have the ladder there. In other cases, you had a front and rear, and because of the layout of the elevator, the governor rope and tension weight was exactly where the ladder would go. So in those cases, even on a handed door, you put the powered retractor ladder on the opposite side, and it comes out to the pass side, very close to the view line of the elevator. Let's run it up. You can see it going up. It takes about 12 seconds to go up. Listen to how quiet this is in operation. Again, at the top, there's going to be a limit switch built into the actuator that will stop it. And I'm still holding the switch, and it's completely stopped. At this point now, that forked switch penetrated the switch, so now that safety circuit is closed. Earlier I mentioned the key switch to operate it. That's what we call option B. I'll tell you a bit about option A, and that is where if you plan ahead and you get the elevator control manufacturer, like Smart Rise or Motion Control Engineering or GAL Galaxy, they will supply the circuitry and the power supply for the ladder built into the elevator controller. So you wire it through the hoistway wiring. So then the standard hoistway access key switch to raise the elevator up becomes the operating device to power and control the ladder. The way it works is you put the elevator on access, you step out in the hall, you turn the key to raise the car goes up, the door is open, you hold the key to the car hits the access limit switch and the car stops. At that point the controller sees that the elevator is at the access limit and it does the switching to power up the ladder. So you're holding that key to the up position to raise the car stops, the ladder powers up, and the ladder lands. And as soon as that happens, that switch, again, opens the safety circuit, but there's a normally open contact on that switch as well. You use the normally closed contact for the safety circuit to the pit switch. The normally open one isn't used in option B, but for option A, it is used. That's wired back in a loop to the controller, so the controller can see that the ladder has been deployed. So you're all done on the pit, you leave the pit, you turn the standard elevator hoistway access key switch to the down position, but the elevator doesn't move because the elevator controller sees that normally open switch is now closed. So instead of moving the car, it powers up the ladder. The ladder retracts up against the wall, locks into place, That switch changes state. The normally closed switch is now open, and the open switch is closed, and then the elevator descends. So that's the ideal way to do it, but that does take some coordination with the elevator control manufacturer. So option B is if you can't get that done with the control manufacturer, or if it's a retrofit in an existing elevator. One other point about where to put that switch: if you had a center opening configuration, wide car, center opening, well, there's no place to mount a key switch like that because the doors are on either side of the entrance. So we found the very best place to do it is to mount it directly under the sill in the fascia. You always have that sheet metal pan extending down from the entrance sill, and it's typically at least 5 inches behind there. Plenty of room for that roughing box. So you just cut a hole in it and mount the 2 holes, mount the faceplate right over the top of the fascia where the roughing box is mounted behind the fascia. So you get down on a knee and put your hand below the sill and turn the key to raise and lower the ladder. And that works very well. A couple of words about how to mount the ladder. There's a complete installation manual which comes with each ladder with instructions and pictures and details of how to mount it. And what we found with this ladder, you're better off to deploy it is to power the ladder up. Again, it's not installed yet, so what you can do is just hot wire this. There's 3 wires in here, a common out of the box. The wiring diagram shows that there's terminal 1, 2, and 3. Terminal 1 is common, terminal 2 is for up to retract the actuator, and terminal 3 is to deploy or extend the actuator. So we ship it together already mounted to all these brackets, as you see, with a section of a ladder already mounted to it. So you can set it on the floor and just power up the 110 to the 3 contacts on the left side here. Bring the 110 in, and then you close the contact between 1 and 3 to extend the ladder out. So extend it out so it's at 90 degrees. I'm going to do that now to show you. This is pretty obviously installed. When you're setting it up, run the actuator out so you're at 90 degrees from the bracket in here. And then this is going to be resting on the floor. What I think to do is you can either pre-assemble all the ladder sections, or you can do it one piece at a time at your choice. Typically this is the layout where you're going to have a pan at the base here with its own brackets. So if you measure up from the pit floor at the wall up to the first point here, based on this dimension, you'll find you may be in trouble because very often pit floors slope. So what works better is to take the bottom section with the pivot pan on it, bring it over to the wall, have this set up straight, put a level on here, get this leveled off, mark these holes, put the anchors in if you choose, and then start adding the other sections. And then you can measure from point to point. You can also run a level to verify, because it's important, of course, on all these ladders that your pivot points remain parallel, so the distance between the pivots are all equidistant. Otherwise, you're going to have some binding. A powered ladder is so strong that it'll overcome slight deviation if you get a little bit of a offset on your drilling, for instance, for a wedge anchor. As far as wedge anchors go, they're 9/16 holes, so typically it's sized for a 1/2 inch wedge anchor. Now you may have a divider beam here, you may have a multiple elevator hoistway, and you may have a divider beam instead of a wall, in which case you can add some sort of structure to be able to attach to structural iron or whatever you want. Every installation manual includes a typical drawing showing a divider beam installation where you can add double unistrut with typical common bracketing to the divider beam high and low. Then I think we talked already about locking it in position. I mentioned that earlier on. Once you get this thing set so that the ladder does not have to be hard to the ground, you don't want to have this thing forcing it down so that the limit switch stops. The key is so the limit switch stops in both ends of travel. And you want to make sure that it retracts it completely so that you get that tight 6 1/4 to 6 1/2 inch dimension. You also want to make sure that your mounting surface is very straight. You don't want to have a deviation of probably more than, it could probably handle a 1/4 inch, but I would try to keep it down to 1/8 of an inch or less. So if you use a laser or a straight edge and you find that, well, I've got a belly in my wall, you can always shiv it out high and low so you get a straight line. Again, these are typically mounted straight onto the concrete or the block wall or your structural steel if it's a divided unit situation. So let's just, for fun, let's run it up and down again here, if you can see it going. This is the second generation powered retractor ladder using the Linux actuator. The first generation used the Warner power actuator, which was a 115 volts, and it was frankly a lot louder and had a ball D10 clutch at both ends and travel instead of a limit switch. That's one of the reasons why we went to this. Also, this being a 24 volt system, it's IP67 rated, which is NEMA 4X rated. So this could be down within the 48 inches of the pit floor, where the code requires, if you have sprinklers, that it be NEMA 4. So we got that covered at NEMA 4X, including the box up there and the glands. It's all watertight. Also, the switch itself for the safety switch is IP. I believe it's IP67, either 65 or 67. So thank you very much for watching this video. If you have any more questions, get a hold of me, Rich Blaska at Smart Elevator Tech, 415-819-5744. Thank you much and have a good day.